Hello fellow shape enthusiasts and welcome back to another episode of Shapes to MAM series. Do you guys remember when you first started the game and it said this is not an idle game? Well, we're gonna prove the Vortex company wrong by building a MAM or a make anything machine, which is a factory that takes one of every color and one of every shape and can output anything. So a quick recap of what we've done so far. We've got our belts coming in with all of the shapes. They're going into these quarter cutters, which is turning each shape into 4 belts of quarter shapes. They're going into these quarter selectors, or shape selectors I like to call them, which is reading off the global milestone shape and selecting the correct quarter to then try to piece back together. But before it gets pieced back together, last episode we built this new painting array. So there's 4 of them, 1 for each quarter. It takes in all of the colors. There's 28 belts of colors worth coming through. So 4 belts of each color are coming through, 7,200 liters per minute. They're being split off into 4 belts of 1,800 liters. Then they're going into these painting arrays, which is selectively routing the shape based on the color that we want. Once that's all done, it goes into our combinator, which is just a bunch of swapping arrays with a bit of smart circuitry on the belt reader that has a blank bypass in case there's nothing to merge. Then it outputs the final shape. As you can see, that's our milestone shape that we want, and it is doing it. Just by itself, no intervention required, turning the game into an idle game. So, what do we need to do this episode? I think we need, like, at the moment it is being able to create a full shape and a full colored shape, mind you, but unfortunately I feel like the mess that we've created is really slowing down our MAM. Every time the shape changes, you can imagine all these shapes need to flush through for ages, and it takes ages and ages. So before we can add any new capabilities to our MAM, such as making pins or adding crystal layers, we need to refactor our code. And for all the non-programmers out there, that just means we're going to tidy up all of this, and we're going to try to make it as compact as possible, because the less space belts you have in your MAM, the faster it performs. And it's taking quite a long time for me to troubleshoot, debug any issues that it might have. So I think it is worthwhile, before expanding on our work, to clean up what we've done so far. So this will be a code refactor episode, guys. But where do we start? There's a few things we need to do that I've been thinking of while I've been waiting to record this episode. The first thing, let's start with something easy. I currently have all of these things that do circuitry are being read off their own individual global wire receiver. See how this global wire receiver gets the operator shape, performs the operations on it, and then sends the signal to say, oh, I want a square in the top right? But when I'm troubleshooting, like for example, right now, the global whereas the global milestone is this uncolored shape, but say I want to test colors, right? And like, how would I do that? I have to go here and like manually wire in like a signal, a hard-coded signal that I want to test, and that seems annoying. And I have one on every single platform here, that's 4, and then there's another 4 on the coloring ones. Oh, by the way, I did make a little mistake on the coloring ones. I didn't actually put in the rotators, so they're all coloring based on the top right shape. Maybe I should quickly fix that bug first. So basically the top right is fine. That's the first platform. The second platform, I believe, is this one, which is the top left. Yep, so it goes around. So I need to add a rotator every time I go up. So this one is also reading top right, which obviously they're all responsible for coloring their own individual quarter shape. So this one should actually be top left, and we should add the rotator on. So the rotator is a simulated building, so that should be 1 rotation to get the top left shape, and I should probably get rid of all this excess crap while I'm here. And the top left shape, I guess at the moment, is nothing. It's blank. That's fine. Then we will go to the next one, and that should be the bottom left, I believe, and that should have 2 rotators on it. That's the diagonal shape from the top left. If you are wondering, I think the way the game reads it is that top right is quadrant 1, and then it goes like sort of around anti-clockwise. So if we get the simulated building for that, we can just put 2 in there, and that should be done. And we will of course configure our label to say bottom left, and then our final one is bottom right. So we'll quickly do that, and that should have 3 rotators on it. And cleverly, I left enough space to do just that. So let's put that on and fix that bug. This is going to be a bug fixing episode, guys. So strap in, grab some popcorn, and let's get to it. I think bug fixing is probably a programmer's least favorite job when they do stuff. They don't want to go through their system, test it, and bug fix, but I'll try to make it as interactive and as fun as possible. So what I was saying about testing is, right, say I don't want to test this shape right now. I want a shape with like some blue and purple in it just to check if this stuff is working. How would I do that? I would have to go here and like get rid of this and then wire in the manual signal 8 times with these 4 input signals. So what if I create what's known in the programming world as a global variable? What I mean by that is, can't we, instead of having these global receivers all receiving random operator shape 0, what if I tell them to receive channel 0, which is nothing at the moment? But if they're all receiving channel 0, I can have a centralized control for what goes into channel 0. So I can tell channel 0 to broadcast operator shape 0, and then it's all controlled centrally from one area, like our main operating base, right? Instead of having to do this all separately. So I get that to be all channel 0, and I'll show you what I mean if you guys don't follow along. That's okay. These concepts are like, I'm barely grasping most of these concepts myself. So if you guys don't get what I'm talking about, it's perfectly fine. I think if you just watch, it'll kind of make sense, hopefully, what I'm doing. But sometimes I do super dumb stuff as well. So you might be watching and being like, what the heck are you doing? You shouldn't be doing that. But anyway, now all of these 8 platforms, instead of reading the operator shape directly, they're reading channel 0. So I need something to broadcast onto channel 0, and what better place to do that than our home central control. So I go to my home central control and I move this, so I should change the marker for this thing. I called this main, as in like the main part of a programming function, but maybe I should just call this home or something. So I'll make a new marker and we'll give it a cool little thing, and then we'll call that home, right? So here is where I want to do the control. So I can broadcast on channel 0. I have full control of that, right? So I can go global wire transmitter and broadcast. Now, if I get that to broadcast on channel 0, whatever I send here will be broadcast and picked up by everything listening to channel 0, which is all the stuff on my thing. So what we can do with this information is, if we put down a global wire receiver like this, we can get this global wire receiver to do whatever we want, say like read channel 0, feed it into this thing and have it broadcast on channel 0. That, you might say, is super redundant, Alan. Like, why the heck did you do that? Because wasn't that exactly what was happening before? Well, yes, I mean, similar. So if we go to any one of these reading on channel 0, let's just confirm that it is indeed now still picking up the milestone shape, which it is, as we expect. Excellent. But what I can do now, if you haven't figured it out yourself yet, is I can very easily change this to a custom signal. So say I want to test a different shape, right? I can just cut this belt and go, all right, I want to test this shape with the red crystals, right? Because I want to do some stuff with crystallizing, and my global shape doesn't have something with crystal. Oh, this is done. Let's claim that. Oh, our new global shape has blue emerald. Excellent. Anyway, so yeah, say I want to be like, all right, now I want to do stuff and testing with like crystals or whatever. I can just send in my own signal to this thing instead of the global signal. I don't have to go replace it at 8 different spots. Now everything should be receiving this signal instead, right? Let's go. Well, do we need to confirm that? I'll just go confirm that anyway. But if we go here and drop a display, now it's going to get the new signal without me having to go change it in 8 different places. But can we do better than that? Is there a way I can make this so like it can like toggle between this signal and my custom signal? Let's see. I'm sure there's like a wiring mechanism. Like, what if I do, like, what if I AND these 2 signals together? If I AND these 2 signals together, will it just give me, well, that doesn't give me any control. What does that even give me? It just gives me a 1. It's like, all right, cool. There's a shape here. There's a shape here. 1. Useless. What can help us? I want to toggle. I want a button. So we're definitely going to need a button of some sort. This button needs to like toggle between this and this. Like, how can we get that to happen? I wonder. What is here that can help us? And or equal gate? Oh, yeah. Gate is a thing that toggles, right? So if I have a signal coming into a gate and then I toggle the gate with a button, well, let me wire it so I can control it. Then I can tell this signal to turn on and off, right? Isn't it? So I can be like, on, bring that signal. Or off. Oh, and then I just do the opposite on this gate. Yeah, that makes perfect sense. That'll be cool. So let's put a gate here, right? And then this is the output of this signal. The gate is controlled by this button. And if I just do the same thing here with another gate, won't that give me exactly the result that I'm looking for? So if I now merge the output of these signals into here, maybe put a display on there to tell me what signal. So no signals coming out because nothing's being controlled. If I toggle that, then I'm getting this one, and I just need to wire the gate to that one, right? Is that gonna work? Conflict? Is that conflict? Oh, right, I need to wire the opposite signal of this gate. Right. So the button needs to toggle. So we have gates to do that, don't we? It's called a NOT gate. Not that. Yeah, now we've got this. So it's going, the button controls this. Whatever it's doing to this gate, we need to do the opposite to this gate. So right now, this button is turning off this gate. Right? Is that what? It's turning off this gate. So it's stopping this signal from coming through. If you ignore that, sorry, if I cut it here, you can see this signal's not actually coming through the gate. So this signal's being blocked off here at this transistor. It just looks like it's coming through because this signal wraps around and touches it, but it's not actually coming through this. Only this signal is coming through, and that's why it's not confused and it's taking this shape, right? What I mean by that is now if I click the button, let's see what happens. It works. Look at that. I created a toggle circuit. Amazing. So now I can very easily control the shape. I can be like, all right, I want the global shape right now because the global shape has color on it and I want to test this thing. But also whatever I want to test, I can do this. I mean, like if I want to go, I want to test my pins now. I want to do some stuff with pinning, right? So I can configure this to be like a pin shape, and then I can feed that through with this button and go, okay, I don't care about colored single layer shapes anymore. I want to test pin shapes. So then I can get this to feed the pin signal, and that should then broadcast everything on channel 0 to everything that's receiving channel 0. Wonderful. That's the first little improvement I wanted to make just for troubleshooting. This doesn't help our MAM in any way, shape or form. It's just going to help our development process. The next thing I wanted to do was to fix the bug on there, which I've done now. Maybe now we can start working on the actual compactification of our MAM. So the concept is the more space belts I use, and it doesn't matter before the MAM starts, because these space belts coming in are always going to be packed full, right? Doesn't matter how long you run these space belts. When they get filled, they're always going to stay full. But for our MAM, whatever happens within our MAM is going to create lag. So when the shape changes, this thing needs to go, oh, okay, my shape has changed, not this thing. This thing is going to be like, my shape has changed. Let me stop sending this emerald shape and start sending the new shape. And by the time that goes through all of this belting, all of this belting, all of this belting, you can imagine how long it takes before a shape changes. So space is very important, and we should definitely fix all that up now, because if you imagine what's going to happen next, whether I add more functionality like pinning and crystallizing, or whether I start working on multi-layered shapes, it means whatever I've done here, I'm going to have to copy across 4 times to create the 4 layers. And if I copy this mess across 4 times, you can imagine how crap our final MAM is going to be. It's going to be the slowest MAM ever made, right? So we definitely need to invest some time into cleaning this up before we extend its capabilities. So enough chatting, let's get to it. The first thing I want to do is clean up this mess of cables, and I've been thinking about some ways to do that, and I need to test whether it works. So I'm going to start by cutting this out and just leaving it here. I want to clean this up, and the goal of this compactification is to go for least amount of space belting possible. All right, so let's copy one of the cutters first, and we will wire it into our 4 outputs. I might put the outputs back together just to see what I can do with them, because even this extra routing is, oh wait, no, I said the inputs don't matter. But yeah, let's just see what we can do with them, right? So we've got 4 inputs in. Now, the way I've had it before was not very efficient, but let's see if we can make that better. So the cutter still stays the same. I don't care about what's happening in the circuitry. I just want this to not create, I want to use the minimum amount of belting possible here. So when this comes out, instead of having this tangled mess of stuff with all of these different ones, what if I just have it select one of each shape first? And what I mean by that is, let me just move this out a bit and keep them all even. I don't know if this is going to work, by the way, guys. I haven't actually tested any of this. I just had some like thoughts, and your comments all helped me sort of organize my thoughts a little bit. And when I reply to your comments, I kind of have, it forces me to question things, right? When I respond, you guys say something like, oh, why don't you do this? And then I type a response to articulate why I did or didn't do something. And then it forces me to go, why didn't I do this? You know, it's really good, guys. It's really good. Keep the comments coming. I'm going to do that. And that one's going to go here. And then I might just flip these and do it there. Nope, not that flip, that flip. And do 2 more here like this. We'll keep it reasonably symmetric wherever we can because everyone here loves symmetry. All right, cool. So we've got all of our inputs, and instead of creating this giant mess we made, and look, this may not work and I might end up with a giant mess anyway. So instead of creating all these 4 together, why don't we do one platform at a time? Will that work better? So what's the main platform? I think the main platform is top right. Yeah, let's do the top right platform first. And the top right platform needs to take in one of every shape, I believe. See, it takes in one of every shape. It doesn't care what order the shapes come in, I believe, because all it does is filter it based on the brain over here. So let's just put this, maybe I want to do it all centrally like this. So at the moment I've got this cabling, and I think we can try to make this as compact as possible, right? And I said I want the least amount of space belts possible. We will use some excess space belt where it makes sense for clarity of design. So that gets me my first quarter out, right? And now that my first quarter out and these belts are consumed, they don't need to go anywhere else. That way I can just make my next belt. So these are the next 2 belts that need to come out, and they need to go into another one. So where can I put that makes sense? So this is the output. Let me just put some down somewhere, and then we'll see where it makes most sense to compact. So I can just put this not here, but like here. No, we need to give at least some space. Then how do these wires come through? Or what if we then take the output, instead of the output coming out here, why don't we get the output coming out the side, right? Then we can get 4 more cables coming in the middle just like this. So this cable would come here. Oh, this is still going to be a little bit long, guys. Or is it better to get them all down here, or is it better to have them even? It's an interesting question. I feel like it's a less messy thing, but then by my 4th platform, this cable is still going to be very long if I keep going that way. Can I somehow even out the platforms horizontally like this? I mean, it won't be even or symmetric, but at least it might be. Let's just try. No harm in trying. I think I need to give some extra room for the other cables. Let's get 1 in here. Wait, this is taking it all from 2 shapes. What am I even doing? This doesn't even work. This is craziness. I need these. I need 1 of every belt. What am I doing? All right, so I need 1 of every belt. Let's take this belt, and then like this belt and this belt. I don't feel like this is making anything better though, is it? I need 1 room for everything to jump. What? I had something in mind for this. How come it's not working the way I thought? All right, let's try something else. So yeah, anyway, 2 belts in, and then we'll bring 2 belts with 1 space for everything else to jump. I don't think, I have something in mind to like compact it a lot, but I don't think it's going to compact as much as I think. Let's just try it. There's no harm in trying. You can try stuff and be wrong. And that's perfectly fine. If it is, I can just always time lapse through the trying process and just show you guys like a time lapse of me doing all this and failing. So yeah, these are 1 of every shape now, right? And this is the output. Let's get the output out somewhere else, and then we can bring more cabling through now. So we can go like that. I need room. I need room for all the other cables. I don't think this is going to shorten my belts very much, eh? I can shorten it all by 1. I can see that by just moving it back 1, right? Because all of this stuff that I have coming out doesn't need to come out directly there. I can cut all this. These can all be directly go under. Then this can come out like that. That shortens it by 1. That's good. Can I shorten it again? No, this needs some sort of room to do a hop. So, all right, let's get the second cable out of everything and put it somewhere. And I don't want to put it underneath with extra twirling. I kind of wanted all these cables to just go to the next section. So maybe something like, okay, the second cable for each one. So this one can go directly, I guess, into, like, say I put my next platform here, then this one can go direct. This one's second cable needs to go out and under, like that, and then it can go in. I don't feel like this is going to save any space, is it? Is it going to save any space? What if the output of this thing goes up? Then I can save some tiles here. one tile. I mean, every tile is precious, right? And there's no reason this needs to go up. This cutter doesn't need to go out there. It can go out anywhere, right? Oh wait, that's the input. What the heck? Oh, what am I doing with my life? This is not even the right platform. Oh my god. I need one of these platforms. Alright. So yeah, where's the output for this? This is there. Can get the output to go to the side. Doesn't need to go into the middle. Maybe I should edit this. Alright, let's try. Because at the moment, if you look at this side belt is creating one extra tile of space. So let's get this going out to the side and see if that helps us in any way, shape or form. It might not. That's okay. Cool. It looks like it's all still working. Every level is still working. I don't want to paste any errors through. So now we can take this and we can rotate it, right? So if we Control X that and then we F it, then that goes like that, and that at least saves one tile of space for me. Every tile is precious, guys, remember. So if we get that going up and out of this area, then we can see, can we condense this anymore? No, I need at least one tile of space to jump here. Do we need to have all of these like this? Not really, I don't know. But we'll just get this back first. I think this can be a bit closer. Maybe they can be, like, it'll help. Every little bit will help. There's going to be a limit to how much you can condense all this stuff, but every little bit helps. Let's get this out. Now, how much can you jump? Oh, you can jump perfect amount. But I imagine that's going to change very soon because I need to get the rest of the cables out too. The belts out. Stop saying cables. It's not a cable. It's a belt. This one is struggling a little bit because of this output. Can I get this output going a bit under so it doesn't intersect like that? Then can this come out? It can't come out here. It's annoying. This doesn't help. Because how am I going to get this one out? Through here. There's no way. I'm not seeing it. Let's just do it and see if it's compactable later. I mean, it's still a spaghetti mess, but I feel like it's slightly less of a spaghetti mess, and it definitely uses less stuff. I might use the right platform so that it actually does its job and not use the cutting platform, but that's fine. It's easy to replace. So now my top right with one rotator, it's top left, and these are still receiving on channel 0, right? Yep, cool. And we want the rotator, one rotator, then we put bottom left. And that's 2 rotators. Oh, not actual rotators, guys. Signal rotators. 2 signal rotators. And then we can do bottom right. No, bottom left? Yeah, bottom right. Just like that. 3 over here. And we're ready to go. We've got our selector back online. Let's see if we can't clean up any more belting. So this is the minimum amount of belt for me to clear this area. And then this is ready to input into the new area, right? Maybe I'll just clean up some of this excess belting too while I'm at it. Not that it really matters. Like I said, the input part is totally fine. It's just the output. We'll do one out. One extra tile of belt for cleanliness isn't going to matter too much in the grand scheme of things, right? Great. And then we can wire this off into our coloring array. And we want to do that as cleanly as possible now. I don't think there's any other bugs in my coloring array I wanted to fix. Maybe I will do just like a little bit of cleanup on these. Oh man, there's a lot of stuff here to clean up. I should have fixed my coloring bug at the end because now anything I change here needs to be copied multiple times. Are there any other little bugs that I want to fix up on this thing? Oh, somebody suggested I don't need this uncoloring thing because the end where I'm binning over here, right? This bin is completely unnecessary. This bin is the uncolored stuff. Oh, hooray. You know, I could just get that to come out as uncolored, but I think it's a bit too late for a change like that now. Because I'd have to rewire this whole thing. Obviously, I can't get the uncolored from the end of these 4 belts out into here, but that would be how you do uncolored, guys. You don't need this thing. the end of your belt is uncolored. If it goes through the entire belt, it's uncolored. Very clever. Very, very clever. But this mess of belts is kind of fine with me. So I think this is fine. I think the order of the color is going to stay the same, definitely, because I ain't doing that again. But I think we can definitely move these somewhere that it makes a lot more sense, right? So let's take one. Where will we bring in the colors? I'm just thinking, trying to like visualize this. Give me a second. All right, before I finish my visualization, I just noticed one thing we need to do, which is the rotation array. Where is a good place? Can I fit a rotator anywhere here that doesn't take extra space over here? I can just put the rotator right here, right? So for the top right, that doesn't need rotation. For the, why doesn't, no, yeah. For the top left, I need to rotate it counterclockwise. So Shift 7, rotator counterclockwise, like that. Then for this one, it should be 180, and then the last one should just be clockwise, right? I think it's cleaner. Like, it looks more compact than this mess. Like, if we compare it, is it more compact than this mess? I guess it is. And more importantly, the output of these have the same travel time now, so that when the shape changes, all 4 changes at the same time, and these all still look like full belts. And it is giving me the 4 parts of the shape I'm currently trying to make, which I will highlight. Still, no one's told me whether I can pin the constantly changing milestone or not. I'm not too sure. But yeah, where do we do the colors, guys? That's the question. That is the ultimate question. Let's reorder this. Not reorder this. Let's just cable this over here. So I take this mess of cables and I cut it. I can just move it over here, like there. Probably like that, and then somehow I take this mess of cables, or this turn thing, so I don't have to redo it myself, over here, and then I just copy this and then shift force it into here. That should recable that in directly. Then I can, oh, why do I have a singular gap here? It's so weird. But then I can recable this part, or do I even need to recable this part? I don't want my cables going upwards, so let's just keep going upwards and see if that's okay. So let's cut this, cut that. I definitely want to save this work here. This is my bypass filter out, right? We can cut these. Oh. I'll take one that's like complete, like that. Copy that. That needs to go somewhere. Where does it go? So as soon as this comes out, I just need to cable it in. This is just the input for this thing. Maybe it's probably smart to figure out where I'm going to put my painting array first. Let me take my painting array out of the way so I see all the space that I have to work with. I just cut that and then my game crashed. Look at this thing. This thing is not liking to be moved. Let's just take one of my painting arrays. Probably we'll take the new one. We'll just start again. Probably easier because I've made edits to this thing, right? Is this cabling all necessary? I guess it is. All right. Let's just take this and ask ourselves, where does this need to go? Where is the closest it needs to go? I can have 4 painting arrays like that. Like that would be the closest ideal place to go. Then where would I put my next one though? Like here. Or should I put them like side by side? But if that's the case, how in the world would I get my color belts in? So if my color belts came some other direction, if I rotated this, the color belts can come in there and the shapes can come in right next to it. I think that's the smart play. We've got to think outside the box, guys. The box is limiting our ability to do anything right now. So if we could do something like that, and then we can like Shift F this, because it doesn't matter. Oh wait, we can't. We have to keep everything in the same order because the colors come in very specifically in that same order. Damn, I kept my thing really so it has to go in like this, but that's fine. That is the correct order that I want it in. I think this is a fine place to do it. 1, 2, 3, 4, something like that. Let's just put 4 down and see, and give it enough cabling, and then we'll shift it to center it. So if we do 1, we need like at least 1 tile of space to do the input cable. And where's the output cable? The output cable is there, but it doesn't have to be there. It can be anywhere. So if we're going to do something like that, then maybe we should edit the output cable too. the output cable can just go like this. I'm still saying cable, stop me guys. Output belt. But this will make the output belt go into the colors array thing, won't it? Where else can it output? It can output back this way, but then it'll hit the colors. I kind of want the output of these. I mean, up makes the most sense, but then it intersects with the... interesting. Let me think about this. Alright, let's just do it for now, and then we'll see what we get. We'll get the outputs going up for now, and then we'll figure out how to hop the cables. Let's just try to cable in one set of this. How do we do that? We need to bring in the cables, and we need it to turn. So it needs to do this funky thing. Everything needs this bypass to peel off the main cable line. And then given the spacing in this cable, I should be able to hop the output back out. But is that the most space-saving way to do things? I don't know, guys. I don't know. So that should connect to this module. And then we should be able to connect this in now. And remember, the initial input of colors don't matter. They don't need to be hyper efficient because the colors will back up. So that's perfectly fine. But let's get the colors in now. Yep, there we go. We got the colors in. We got the shapes in. Then we need to continue this design across. So how can we do that? And I don't mind the output going there because I know it can hop all the way out. Although this last hop looks a bit cagey now. Maybe we should fix that before we do that, because it needs a 2 space gap to hop. So let's do that and that. That way this output can hop out to our recombinators. I don't know if that's the best thing to out. Maybe we go that way, but I want the output to all be even, so everything changes at the same time. So now, is this all correct? That is all correct. So let's take a copy of that. And is that the closest? Before I do that, I should make sure we're the closest possible we can be to this, because I want to, every cable counts, right? So that's the closest possible we can be to it. But no, because yeah, we'll go down 1 tile. That way we have room to play with in case we need to do any like weird turns or anything like that. All right, let's cut this all down 1. Oh, it takes so long for me to cut and paste now, guys. Every space belt tile we save right now is a win. So now I can copy this 4 times. So I need 4 of these. So is 1 tile spacing enough? I hope so. 1, 2. This does include my output belt, so that's fine, right? Well, we're about to find out the hard way. So that's a little bit not even. So I can take this whole thing and I can even it back out, right? Let me just cut these cables and center this a little bit. I think I need at least 2 spaces here, because this needs to turn and do other things, right? Where's the center of the output? Here. So I'm just trying to measure where these cables go. I guess 1 cable can just go direct. Then I need that to do that. 1 belt can go direct. I think I need to go up 1. I'm thinking I need to go up 1. So let's just cut all that up 1. Oh. Cut all that up 1 like that. We can copy that and put that there, and copy that, and then just do that. Oh, that worked. All right, great. Doesn't matter which way space belts go. Excellent. So that should get my color. It should peel across. I probably need to connect everything properly, like that, that, and that, and the top one as well, like that, that, and that. All right, that should get all my color stuff working. Great. The colors do not need to continue forth, and I probably need to fix that because that's going to continue to attempt to split my color belt, and I don't want it to keep splitting my color belt because this one's the last one. So definitely doing a lot of debugging and cleanup this episode, guys. Make sure everything is perfect. So that's looking good. Now we need to route the input of this into our 4 different painting arrays. I think this makes it a lot more readable as well. And by readable, I know like I don't have to trace my belts back to, oh, what corner is this and what corner is that? You know what I was doing last episode? Well, I know you probably don't because I fast forwarded through all that crap. But yeah, it'll be easier to debug when you're clean, guys. Always clean up your code, clean up your work, clean up your messes. You know, you got to clean the kitchen while you cook. You don't just like make a huge mess and then clean it at the end, right? It's a big task. If you just clean all your little bowls and plates as you're cooking, and then you have less of a mess to deal with when you finish and you can go and enjoy your meal. Do we need all these kinks and stuff? Should we clean that up too while we're here? We probably should. Nice and clean, guys. Nice and clean. All right, great. So that's that. I think that's all working. We're gonna test it. All this is still working. I mean, it will be working once I get it out of the recombinator. But yeah, basically we need to put in the top right, top left, and all that stuff. Do we need to label these? Oh, we'll just label these to be top right. That is top right. That's fine. And then this needs to be. Oh, that's not it. This needs to be top left. You guys don't need to see me do this, so I'll probably just skip through it real quick in the final edit. But yeah, now the colors are coming through very slowly, and this thing should go through the correct color selector, right? So this is, let's just double check. So this is blue, and then it's going to the blue gate, which is going to, that is not blue. Why is that not blue? That says blue, but blue is now flipped. Everything is flipped. What? Why is everything flipped? I mean, it doesn't matter that everything's flipped. I can easily just flip it. Is that meant to be the blue one? This is meant to be the blue painter, but it's receiving white. Okay. And this is meant to be the red painter, and it's receiving yellow. And red's now, it is flipped. God damn. Think that's fine. It's an easy fix. We just take it, and then we shift F. Yeah. No, it's not a super easy fix because I gotta shift it all that way a bit. I'm going to fix this in time lapse, guys. Okay, guys, I flipped all of them and they should be working now. So we've got different shapes coming through. They'll slowly fill up. Now it should go through the correct color. Let's just double check that yellow is going into the yellow painter. And that yellow painter is being fed. We just have to check one, guys. It's being fed from yellow. Yep, I just had it more flipped. I knew that might happen. That's fine. Now we can get all these outputs out. So they are going upwards now. That's fine. We'll get the outputs out somewhere here. It doesn't matter where. I think this distance needs to be traversed unless someone can think of a better way to peel off the colors off these belts. So unfortunately, this distance is just going to have to be traversed by these belts. But I did leave enough room to get them all out, and we'll get them out as minimally as possible. Can I just copy this one row and put it here? Will that work? Oh, it works. Amazing. Even though it doesn't look like it's about to work, but somehow that works. All right, that will get my output shape out. And then these output shapes need to sort of merge together. I don't like the fact that the space belt looks like it's in my build, like they go into my build, but I don't see a better way of doing that right now. I don't think I'm going to mess with this because it took me ages to come up with this. I don't know how you're going to peel off one of each color off a belt series like this, but yeah, I think I like the way that I'm doing it, and I think you do need to do this much space when you're working with this much crap, but we'll see. Unfortunately, I need to create one bit of space here, but we will center this as much as we can, like that. And then we'll start working out on our recombinators, actually. So we'll do it as central as possible. The reason I do it central is that so it's not just for looks anymore, guys. It's for functionality as well, because we don't want to be lagging off one tile. So we need to combine two things and then combine two things. Are these two things the same things I want to combine? So it is that we want to combine the top shape, right? So top right, top left is coming up directly. It's a lot more readable now into this top left, top right, top left. Yep, and then those two are coming out and they need to be combinated. So we can combinate here. Where's my combinator? Oh yeah, I was going to redesign my combinator too. So a couple of you have suggested stuff for this, so this is going to be a cool little redesign. So there are two changes that I thought of because of your comments for the combinator. So let's grab our combinator. Where is our MAM series? Dynamic Shape Combiner. And let's have a look at what it's doing. So the way I've currently structured it is that it is reading off the belt readers themselves. And I don't like that because as you saw last episode, it was having issues. Whenever there's a gap in the belt, it suddenly thinks, oh, I'm not meant to merge that shape. I'm going to bypass. And we don't want it to do that anymore. So I'm going to go up 2 layers. I'm going to delete the top layer and we're going to rework this thing. Did I delete both top and mid layer? Nope. I'm going to delete the top and mid layer and then I'm just going to work with the bottom layer. But before I do that, I'm just going to quickly delete my work over here because I think it's like lagging my computer. So I don't need those painters anymore. Goodbye. And then this combinator, there's two fixes that I want to do to it. First, I want to fix this wiring so that it reads off the global signal rather than this signal, right? So this thing's going to need a brain now. And I have no idea how I'm going to get this to work. So let's figure it out together. I might have to redo some of this wiring because how am I going to get the wiring into there, right? But we'll figure it out. We'll try to do one and then we'll figure it out. So basically this thing is combining, but the bad thing about this change that I'm going to do is now these are going to be platform specific because it's going to read two specific signals. So this, before this was agnostic to whatever I put in here, I can just use the same platform for combining bottom part, bottom left, bottom right, top left, top right, and then even the two halves. But now it's not going to work like that anymore. Now I'm going to need my brain to tell it, well, this thing's going to need a brain to tell it what to do. So this looks like the biggest space to start with. So how am I going to build this brain? I'm going to get a global wire receiver, and that's going to receive channel 0. So at the very least, I need to know the channel 0 operator shape. Well, the shape that we're trying to do, right? And then I need to know two parts of this signal, not just one. So we'll do the top first. So I'm going to split this signal out. And one of them is going to rotate. That's going to give us the top left and the top right signal, I believe. But we'll test that with different displays in a second. So I'm going to pump everything through a display just to, well, let me take that. Oh wait, no. Once it rotates the shape, it needs to go through a signal analyzer. Let's put a signal analyzer down. I'm really hoping I have enough space to do all this, guys, but I don't know. So where's my signal analyzer? It's over here. The shape analyzer. So it's going to go through the shape analyzer and then it's going to pump out two shapes, right? So my display is going to go, oh, these are not displays. I keep confusing buttons for displays. So these are going to be like the top left and the top right shape. Now I need to check if either one of these are null, and that's the signal that is going to feed into my belts. And someone taught me a super easy way to do that using just a simple AND gate. So if it's an AND gate, it's going to go like that. Oh, that's not the signal. That one, and it's going to go that. And then the output of this AND gate will tell the belt whether to turn on or off. And again, I can, wait, before we do that, let's do this at our home location. That way I can play around with the signal. What? I just clicked home. No, that's the current. We'll go to home. And then we'll do this here, right? So if I have this signal, obviously this has a shape, but if I'm missing half the shape, this should turn off now. So let me toggle that. We toggle that to my current shape, and then I want a shape that's missing part of its top half, like for example this shape, and that's missing its bottom shape too, so that's perfect. So if I configure that to be my signal, now that's transmitting, it's receiving random, I'm meant to receive that. See, look at that. Now it knows that the bottom half of my shape is a nothing. Maybe I can put some displays on here to make it more apparent to you guys. It knows half the shape is nothing, and then the AND gate just turns that signal off or on. And it even works with null. So that will, this is the signal that will control our belt filter now. Is there a cleaner way I can do that? Can I put my AND gate, like I want to just make it as small as humanly possible, even if it looks confusing, because space is at such a premium now. So if I just directly wire one side in, yep, like that. Maybe this can go here, and this can go, no, I don't think so. Look, I can probably, someone can probably condense this more than I can, but I think that that's good enough. And we just do something like that, and that's the output signal we want. So this is on channel 0 red, and that is everything I need for the first one. Oh, but I need to leave room. I need to leave room for this to have more. Oh, damn it. So we'll put the AND gate up here. That would make sense, right? Put it like that, and then that way this can have room for up to two more things, because the next two shapes need to rotate. Oh, actually, but then that one needs to rotate too sometimes. Rotators. Okay, we'll leave enough room for 3 rotators on each one. 1, 2, 3, like that. Well, one of them only ever needs a maximum of 2 rotators, so let's do that. And then something like that. That way there's like, because the bottom half of the shape, one's going to need 3 rotators, the other's going to need 2 rotators. So I just want it, all the stuff to be uniform, and then we can work with it. This is going to be my top half. So this platform is now going to be specific to top half. And the other thing I wanted to test was, can we make swappers direction agnostic? And by that I mean, like, say I have an input of Let me go to a different asteroid. And you guys probably already know how to do this, but I don't know how to do this, so I'm going to test it. Alright, say I have this shape. And it's worth testing this stuff in abstract before you go and overcomplicate your MAM. Make sure you always test your theories. So say I have this shape and this shape, right? And then I bring this cabling together. I'll bring it both halfway so we're not waiting for one shape forever. And we just put a platform down. Then, what I mean by direction agnostic is, I don't care which shape I wire to which input, right? If I have a cutter, so this shape is this shape. At the moment, if I have a cutter, oh sorry, not cutter. Yeah, it is cutter, sorry. I keep forgetting the swappers in the cutter. So that gives me that, right? See how it gives me the shape on this side? And like I currently have it wired something like this, and this is going into the trash, right? But then, what's going to happen is if I accidentally flip these around by accident, something like this, for whatever reason, I miswire it, or the shape comes in a slightly different direction for some reason. Now my shape's going to get produced on the other side. See, nothing's coming out, and my shape is going out here directly into the bin now. Right? So what I mean by making it direction agnostic, why do we even need a bin? Because when you're merging shapes like this, one's always going to be blank and one's always going to have a shape. So instead of a bin, why don't we just merge the outputs? Silly. Silly, silly, silly. That makes perfect sense. Alright, so we should definitely go and do that. Let me go back to my thing and we'll edit this a little bit, and that will clean up this significantly. Look at this. We might even just redo this whole platform. Let's just redo this whole damn platform. We'll get a new 2x2. Never be afraid to redo your work, guys. Always question your assumptions and just keep redoing your work. What we do need is these hoppers. So it's something like this, right? That was our base shape. One hops in, one hops in. We've got two input lines and two bypass lines. And the bypass lines and input lines work off these belt filters. So it's something like that, right? And we might even test it with the actual shape. So if we put it here, and it's going to be direction agnostic, we're just going to start this process again, guys. We're going to redesign this from scratch, because sometimes it's just better to like uproot your code and redesign it, because I've completely compacted this now. I didn't need that whole bin thing going on. Maybe I will put down my original design for you guys to compare. But yeah, we don't need this to be so massive anymore. See how we've got all this extra belting to deal with the bloody bins? Had I thought about just merging the belt out like this, problem solved, no issues whatsoever. And then we need a new, because we need to redo this wiring as well, right? We don't need these belt readers anymore. We just need regular belts, and the wiring is going to simplify significantly as well. We just need a brain somewhere. Where's our brain? Uh-oh, I deleted my platform with my brain. No, I don't want to undo everything. Damn it. All right, I'll just rebuild the brain. That's fine. All right, I'm back, guys. We're done. We rebuilt it. All right. So this merges top left and top right. Actually, I want my signal to go back to the normal signal now. So if I go back to my home, all I have to do is toggle this back to my actual signal that I actually want. And my MAM will start chewing those shapes out for me. It never seemed to, oh wait, it never seemed to stop changing because nothing was happening. It had nowhere to go. So it hasn't flushed the old shapes out yet, but that's fine. It's exactly what we want. So let's change this. This is the top left, top half, top half. Where's the top half? Perfect. So this is the signal for the top half. It needs to wire into both these belt readers. Is this belt reader configuration the best that I have right now? Why are they so spaced out? Because I needed a signal thing in the middle. Do they still need to be like this crazy anymore? The answer is I don't think so. Why can they not just be like that? Then one can go shift 1 1. One can just go like that. One can go no. One can go here. Still needs to split off into 4. Into the middle doing the bypass is still the most efficient way of bypassing. So, and I need one space in the middle to pull the cable in. So I think this is the minimum. I need something like this as a minimum. Need to retest all this, guys. I believe I had something like that. And then I just want to leave one space in the middle to do stuff. And then this can come down. Look, I've condensed it even further now, even further. So now in theory, if I just pull two shapes in, how am I going to get the signal in? So I definitely need space for the signal. So I guess I need a hopper here so that the signal can come in. So at the very least, I need that. And then a cable here, a belt here. Stop saying cable. Yep, that's it. And then, like, for example, let's just test this on 1 before we get too excited, guys. So if we go shift 3 2, we'll get the wire in, and then that should be happy, right? And we'll just double test with a bin that this works. Okay, it's kind of working. I need to knot the signal, and I can just knot it centrally here. It will never double bypass like this because that's just the signal being wrong. Okay, that's fine. Let me just trash this. So I need to I need to knot the signal, right? Just put a knot gate in. Gates. I'm still so unfamiliar with these logic gates. Excuse me. Yep, that'll be the signal I need. And now it goes out to the other side. Excellent. And now it goes for merging. Perfect. 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 I believe that works, guys. I believe that works. Excellent. So I need to re-merge these out somewhere so that becomes an output. And now I need 4 units of this stuff somewhere. I mean, do I need my signal to do this? Let me just move the brain somewhere. Let's get this out of the way. We don't need it to be like central in the world. Is there an easy way to fit 4 of these now that they're so compact? If I go like that, and does it fit? No, it was so close. Can I compact this anymore? I don't think so because of the jumpers. So close to fitting. If I can compact it like 1 or 2 more tiles, if these jumpers can just get out of my way. But I don't think so. I think this is the most compact it can be, so unfortunate. So it's gonna need like 2 in one direction and 2 in another. So definitely gonna put 2 like there and there. We'll keep the symmetry line. Something like this and this, but it needs some space for the middle part to breathe. I did put it with 2 spaces here so the cables can go up, but maybe I'll do it 4 so that 2 sets of 2 can go up. That would be smart. And then we can do something like, doesn't need that much room on the other end, and that. Let's just try this. There's no harm, right? It's kind of, is it mirrored? Yeah, it's kind of mirrored. And it's direction agnostic, right? And what direction agnostic means is I can route in my thing anyhow I want. But how am I going to get my signal in? That's the problem at the moment. If I have my cables in like this, because remember these need signals, guys. These need signals. Now I need my belts to go around my signal somehow. It's actually not as simple as I thought. I don't know how I can build this symmetrically and still route all the input in. It's actually, I thought it would be super simple, guys, but it's actually not super simple. But let's just route around our belts where it makes sense. That's 1. Do the furthest ones away first. Alright, I might time-lapse this while I figure it out. I don't think you guys need to see my logic in doing this stuff. You know how it all works. We've done it a billion times before. These videos are getting too long. Alright guys, I think I did it. It was definitely not as easy as I thought it would be. Definitely not. Still not fully done yet, but getting there. Need like just a little bit more room. Look, I did it in the messiest way possible. I don't blame me, but yeah, I did it in the messiest way possible. There's probably a better way to do this wiring and such. But it's all on one level, so it's easily duplicable to the other levels once I test that it is working at full capacity. Great. It looks like it's working at full capacity. It's all merging. Why is it all bypassing? Alright. I reversed the not signal so I can see the damn thing happening, because I couldn't tell whether the stuff was combined or not. So I had to like reverse the not signal. But now we can get the not signal back, and then we can see if it works. Alright, I'll time-lapse this for testing. Alright guys, I think that's all working. So I'm going to dupe this up for a couple of levels while it saturates itself. I feel like I have all this unused space up the top as well. I don't know why I made this so hard on myself. I think I'm just tired, and I think there's like easier ways to have done that. But let's go up 3 times, and we'll delete the excess crap now that we know there is excess crap that gets copied up. Don't need all that. Signaling. Actually, we don't need any of this signaling. Let's just delete all of these wires here. Oh, not that though. Delete the excess crap, because the brain is down here. It just needs to pass the information up here somehow. And there's plenty of room for it to do that using this cable. So we'll go one out this way, we'll go up 1 level, and then that can go to the 2nd level. And we'll go down, and we'll go out that way, we'll go up 2 levels, and we'll pass that one into that one. And then we can delete all these excess stuff. Yeah, great. Yep. Cool, the processor or the brain is working and it is doing its thing. I'm going to let it saturate, test, and then we can save this new blueprint. So the summary is now, instead of this, where it's reading off its belts, and that could cause issues in case there's blankness in the belts where it shouldn't be, it is now reading off what the actual shape it's trying to make is, and it knows the actual shape needs to be merged. So even if one belt is empty, it's still going to send the other belt into the swappers to wait for that input, and that should be a much more robust solution than what I had before. So we'll let that saturate, make sure it's all functioning at 100% before we productionize this design. Is there any other bugs that I need to fix? But this is, yeah, definitely much cleaner. We don't need to do this craziness with all the bins and stuff, and definitely much more robust in terms of functionality by reading the actual shape rather than reading belt contents. All right, it's a lesson learned from the future. Don't try to read belt contents. Why this is continuously coming out with some purple shapes, I still don't know. I think it still hasn't fully fed through. Let me just check this while I'm here, because I don't like how it's going to purple. It's going to blue. It's definitely going to blue. I don't like how it's doing that stoppy thing as well. Let's just double check this blue input. Is it doing the same bug where it's going dup, 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 and then stopping? Yeah, it is doing that weird bug. I don't understand that weird bug. It's like the painting is like too fast for the belt to keep up for whatever reason. But this is fixed now, and we are getting a full output belt, which is perfectly fine. I think it's just, look how much lag there is in the system. I changed it from purple ages ago and still trying to do purple. But that's fine. I think this is working now. Unfortunately, we can't copy this, but we will save this as recombinator version 2. And we'll put that in our MAM series. You can download all these blueprints on the link in the videos. So we will take this, and we're going to make this the bottom half. Oh, don't do that there. Don't want the shape to go in. Well, we can just do it on the actual bottom half, right? And this is direction agnostic, guys, so it doesn't matter which one you send where, as long as you send it the bottom half of the shapes. Well, this is actually flipped. I don't like that. I'll just... Do I like that? Why is the sign flipped as well? That's silly. Alright, we'll just put it as this. Call this bottom half. And the only thing I need to do with the bottom half is change the amount of rotation. So one needs to be 2 rotation and one needs to be 3 rotation, and then the AND gate will figure it out. And it's telling it no. What? Why is the AND gate no? Oh, it is meant to be no. Yep. It's meant to be. It's not. The signal is knotted. Yep. That's the only thing I don't like about this, is that the signal has to be knotted, and that just has to do with the fact that I've designed the side gate to be the one that we want, and the forward gate not to be the one we want. I don't think I can change that design without losing space. But yeah, it is working, guys. So that's creating me that shape. That's creating me that shape. I think one of these needs to be a little bit further back, and it's going to be this one, because these belts need to be able to route out and create the full shape. So they need to go through a rotation. Is there a better way to do this? Can I... Someone told me if I route the belts out directly above, then I don't have to space belt at all. And I think that's actually a good idea. So let me do that. And I have enough space to do that, right? Let me just test on one. I feel like a lot of this stuff is better to do if I side route, because I've been so in the practice of just whatever direction I come in is the direction I go out. But I feel like a lot of this stuff benefits from coming into one direction and then routing out another side instead of routing out forwards, because then you can collapse these two like closer together, and you'll see what I mean in a second. So I just copied all this up. That should sort that out, right? Right, and that's done. I've got the outputs coming out the side now, and they're flipped versions of each other. What that allows us to do is we can put these closer together. Are they centered? I want them to be centered. I think they're not perfectly centered, but that's fine. So we'll get the input in, and then now that we have the output here, we did need to rotate the output, right? So what does that give me? Once I see one swap shape, I can decide what rotation to put on the combinator. Yep. That's fine. So this one needs to be on to the right. It doesn't matter. It's direction agnostic. So one needs to turn clockwise and the other needs to turn... They both need to turn the same direction 90 degrees either way. It doesn't really matter. Okay, cool. So we'll just do clockwise. So once they've turned clockwise, I don't even need belts. I can just get another one and then that can just input. Oh wait, there's the input and go straight into another combinator, and that will give me the final output. And this output I probably do want to go out directly up to go into the next section, because that's my final shape, guys. That is my final shape. So the brain on this needs to be a little bit different, and I'll figure it out in a second. Great, we are getting shapes. Let me just chuck a bin at the end of this while I figure out the brain. Okay, we'll let that run for a second. All right, so the brain for this has to be a little bit different, right? So this is going to be the merging of final merge. So we'll call it final shape. What I mean by it has to be a little bit different is that this is only checking top half and bottom half. So I'm going to take this signal out, and I'm going to figure out how to modify this at home to get the shape that I want. Alright, I might do another platform because this might be a bit big. I have some idea how to do it, but I'm not too sure. But basically, we're going to get the signal in, and we're going to need all 4 versions of this signal, right? So let's get a wire out, and then let's get 4 of these wires. Go away, Adobe Acrobat update. I don't care. And then one is going to be a direct wire. We're going to need the top and the bottom half shape, so we're going to need to rotate the signal. Like this, and then 2 rotate, and then 3 rotate, right? That's the bottom half of my shape, that's the top half of my shape, and then I need to combine these with a virtual simulated stacker. No, wait, I need the signal analyzer now, right? Next is a signal analyzer. So we need to analyze all of these signals and the shapes that come out of them. So this brain's going to be a little bit more complex, but I think we have plenty of space to shove that somewhere. And now if we look at the display, that should be the 4 parts of my shape, right? Well, at the moment, they're all the same damn parts, but we know that is the 4 parts of my shape. Then we need to undo their rotation. So whatever happens here needs to opposite. So the top is just the top, that's fine. This needs to opposite of whatever happens here. So like that, and that should give me the rotated version of the shape, right? If I get a signal analyzer and a display. Now that's my 4 shapes, right? That's my bottom left, bottom right, top, and top. Now I need that to go through a simulated stacker. The input of that being these 2. Where can I put this? Is it better to do it this way? Probably better to do it this way. And that gives me the stacked shape. And this is the shape we're gonna have to add. So we have to make sure these are both correct, right? So something similar but flipped on the other side, like that. And that's the bottom half of the shape. And this is the signal we have to and then not. So if we get our logic gate and we go and that, then give me a not on the output. And this is the signal that the two belts need to check whether they let it through, because half the shape could be blank and we don't want to do the final stack, right? So we need to account for that. So that is the brain for the final stack. Oh man, is that easier or harder? Now I have issues because that doesn't look like it's gonna fit there. I'm gonna have to put it on this side. Well, luckily I left room because I'm gonna have to rewire this now somehow. That's fine. They're all connected kind of, so I need to just figure it out. I'm gonna get rid of the NOT gate, then I'm gonna do the wiring. I'll probably time lapse this. Alright guys, I think I redid the wiring, so now the thing is on this side. Can I put a text here to say that's the final shape anywhere? Yeah, that'll do. So that's the final shape. And I need to put the NOT gate back on so it doesn't bypass. It's trying to bypass right now and it's struggling because it's not meant to bypass two shapes at the same time. So don't forget my logic circuit, and I'll just delete the top two layers and just copy it up, make it easier. NOT gate. I'm not going to do that again on this layer, right? Do some final cleanup. Oh man, I need to delete all of this. Now I need to bring the signal up. It should be pretty easy. Bring the signal up twice, and that should be pretty easy. Alright, great. So that should be working now. I'm going to let it run to test in the bin for a bit and see if that produces the final. Actually, I'm not going to let it run to test in the bin. What am I doing? I'm going to let it run to test into my vortex, which is right next door now. Well, cut some extra cables. Don't know what that thing's doing. What is that thing doing there? Probably for my demoing purposes. Alright, now let's go into the vortex. It's going to deliver some shapes. Probably going to deliver the wrong shapes for a while, but we'll let that run and we'll see if it sorts itself out. I'll be back. Actually, before I go, let's save this as our new combinator. Because this is, that little thing I saved before is not the right thing. So let me go to my blueprints, and did I do that in there? No, recombinator version 2. We can delete that, and we can delete dynamic shape combiner, recombinator. There we go. All these blueprints will be available in the link in the description, so you can take them, you can play with them, make them your own, and enjoy. I'm not going to charge you guys anything for it. I think someone told me people put their blueprints behind like paywalls, like Patreon and stuff. I'm never going to do that. So you guys feel free to enjoy the blueprints. I think this is going to take a while for the system to flush out. It is definitely using the NOT gate. That and that NOT. Oh, what am I doing? The bloody wire thing is gone. I would have AFK'd here letting it test for bloody ages and then come back and been like, why the hell is it not doing anything? That needs to receive on channel 0. Nope, that's a transmitter. Need the receiver. That needs to receive on channel 0. Great, that'll start working now. I'm going to let that run for a few minutes and then we're going to see if this thing starts flashing. Alright, be right back. I'm back guys, and it looks like it is starting to deliver the right shape to our final thing. I don't need to change the orientation. Well, I did in my last one, right? So I might as well put it through the 90-degree rotator, right? How much is that going to hurt me? That's counterclockwise. So shift 7 counterclockwise rotation. Sorry, it's going that way, which is, yeah, it is counterclockwise rotation. Give it a counterclockwise rotate, and we're done. That took me a full hour or longer than an hour. I didn't realize that it would take this long, but you know, sometimes things just take longer than you think. But look at that, it's smooth. It's much smoother than before. It's doing fully colored painted shapes, and it's doing it at 100% efficiency, I believe. Why is this belt not fully saturated? Is it because I just stopped it for whatever reason? Some of these belts are not fully saturated, and we need to figure out why. Alright, doing a bit of debugging, guys. Yeah, it's really weird, guys. I feel like it's just a game glitch, because I've literally tested every single component part of this with a bin, and it is always fully saturated, and I don't know why the final output is not fully saturated. I might have got my ratios wrong somewhere, I guess. Or maybe because it's doing this bypass thing. Why is it still trying to bypass an entire shape here? Oh, yep. Alright, because the reason why it's trying to bypass an entire shape is because the shape changed. We can look at our milestone. See, we've got a shape that looks like this, but then the top half and the bottom half are both existing, so why is it not trying to merge it? So these two are both going to bypass. Yep, that's fine. Oh, I see a big problem with this bypass. During this phase of the flush, it's going to be super slow because it's going to try to bypass 2 lanes worth of output into the bin before it gets through everything. We'll see if it sorts itself out. But I can see these two things, they should be glowing because they should be bypassing the shape, right? But this thing should be merging the shape because the top half and the bottom half are not both blank. So let me just troubleshoot this thing because I think there might be something wrong with my final shape thing, and I don't want to leave the last episode with a bug because that was the whole point, guys, wasn't it? Shape stacker. Nope, nope. Why is it both coming out of the shape stacker with a null signal? That's weird. Alright, let's take it to home. Let's just take a look. It's pretty easy stuff, guys. Alright, let's have a look. So let's put some displays here. So what is this signal telling me? That's blank. That's fine. That was this shape. Alright, we'll put a thing here so we have a reference shape. It's definitely this shape, right? So then after the signal analyzer analyzes, it goes, display. It goes, the top right is nothing. Great. And nothing stacked with this thing, which is a rotated version of this shape, stacked with the red square. So this should be a red square now, right? Yep. So nothing stacked with a red square should give me a nothing. Oh, wow. This thing needs a bypass. Because it's a null signal, it can't go through a stacker. It needs... What? There's got to be an easier way to do this, guys. I'm not seeing. This is the dumbest thing ever. This should just know to stack that with a nothing. Is there a better way I can logic this? If this or this, if this and this, then it's got to be like, maybe I don't use a stacker and I use an AND gate there, right? So it'll be something like this, I think. It'll go if this and this, that'll be the bypass. Then bypass both shapes. Oh my god, I'm gonna have to do what I did there. What? That's crazy confusing. The top half and the bottom half, how do I deal with that? Basically, it needs to go if this or this is a thing, then that's the signal, right? So yeah, I don't need to stack the shape and then AND that shape. I don't care about the shape anymore. I just care about the signal. So I just want the signal to go if either one of the top has something. So instead of this, I believe this just needs to be an OR gate. I think that's the simple solution. Oh man, this is an exercise in bloody code debugging, isn't it? So if this or this, then that, then not that, right? That and that. Yep, that works. Oh my god. Dude, guys. I don't know if you understood what I said. Let me try to explain it in a better way for anyone that doesn't bloody code or anything. So basically, this thing's not working because I'm doing a stacker, and you can't stack a shape. This line carries a shape. This line carries a null signal. You can't stack that because it's coming out as null, right? This should not be null. This should be the half shape. Sorry, if I put anything in here, a display. If you look at the top half of the shape, it's stacking nothing with that, right? But a stacker doesn't do that. A stacker goes, I have a shape and I have a null. I'm gonna break and give you a null. So these are not stackers, these need to be OR gates, because if either one of the top shape exists, so or top left or top right, then give me an output signal. This game. I love this game. I love and hate this game at the same time. So see how this signal is a thing, this signal is a null, but since there is a top shape, then yes, I want to do something. Then if this is this part of the bottom shape is a null, but this part of the bottom shape is not a null, therefore yes, I want to do something. Therefore yes, I want to stack, null the signal, and then go through the stacker. That's how you do it, and that's how you get this butterfly shape, which is the thing on the bottom. But as you guys notice, we have two layer shapes now. So our MAM needs to go to 2 layers, right? 2 layer shape means our MAM needs to handle 2 layers. Now, I can continue to do this in the order of the shapes that it's giving me, or I can start, actually, it's probably a good time, next episode, not now because it's going to take forever, to start switching to crystallization and pins, because every layer can have crystals and pins, right? So why don't I get my 1 layer shape able to handle pins, able to handle crystals, then I can copy this entire thing, 1, 2, 3, 4, boom, done. And then we will build our final stacking array that can stack together the 4 layers of shapes, and then that's done. That's the whole MAM. We're getting there, guys. I know it seems like we made no progress this episode, but I absolutely guarantee you this was a vital step in the MAM. We could not have, I don't know, I can edit the original footage of what the old MAM looked like before we did at the start of the video, but without condensing it to this, trust me, the final MAM would have been a complete disaster. Because you can imagine when you do crystallization or crystal making and pinning is gonna probably easy. I'm gonna take my words back, but pinning might be easy, but crystallizing, you can imagine, is gonna need another full double belt of each color to go through the different crystallizing steps. Then yeah, I'm gonna need to, I have no idea how I'm gonna do it, but yeah, it's gonna be an expansion on top of this, so it's gonna be even bigger. And then whatever we do, we're gonna have to copy the whole thing 4 times to do that for 4 layer shapes. Hope that all made sense. But that's it for this video, guys. I've gone on long enough. I'm sure you're getting sick of hearing from me now, but I hope you're enjoying the series. I hope you have confidence that we will get this MAM done at some point, and this won't be a gigantic waste of all our times. But otherwise, if you've enjoyed the content, please leave a like and subscribe. It'll really help my channel, and I will see you in the next video.